We're going to take a look at factor and factor trees. We're going to look at understanding factors, understanding prime factors, and developing factor trees. Now, let's start off with a factor. So, a factor or a number has factors if you can find the numbers that you multiply together to get that number. So, what that means here is if I had a number like 6 has factors. The possible factors are 1 and 6, 2 and 3. So what you can see here is that 1 and 6 are factors of 6, 2 and 3 are factors of 6. So if you wanted to list the factors of 6, you have 1, 2, 3, and 6. So that means that 1, 2, 3, and 6 are factors of 6. If I wanted to look at something like 12, I have 1 and 12, 2 and 6, 3 and 4. So the factors of 12 are 1, 2, 3, and 6. So that's how the concept of factors works. Now let's look at prime factors. Remember that a prime number is a number that has only two factors, 1 and itself. And also remember that 1, it's not a prime factor. It's not a prime number. So in the case of prime factors, the factors of the number must be prime numbers. So let's look at the examples we used earlier. We had 6, and we agreed that our factors were 1, 2, 3, and 6. So if you look at this is not a prime number, so it cannot qualify as a prime factor. Now you look at 2 is a prime number, it's considered a prime factor. 3 is a prime number, it's considered a prime factor. What about 6? 6, because it has more than two factors, it cannot be considered a prime factor. So in this case, the prime factors here, I'll denote as PF, will be 2 and 3. What about 12? From what we saw earlier, we have 1, 2, 3, 4, 6, and 12. Now, when we look at the prime numbers here among the factors, this isn't one of them. This isn't, this is not a prime number, and this is also not a prime number. So you can see that 2 and 3 are the only prime factors here, and so our goal would be to write 12 as a product of its prime factors, which is 2 and 3. And that is where our next content comes in, factor trees. So what we're going to do with factor trees is we're going to create a tree-like structure that will show a number broken into its prime factors. Let's start off with 12. So this is what we're going to do. We have 12. We're going to create a tree-like structure. So let's start off with the prime factor. We start off with 2. If I divide 12 by 2, I have 6. Now, if I divide 6 by 2, I have 3. So that means here that 12 is 2 times 2 times 3. You can see that each of these numbers here is a prime number, so therefore they could qualify as prime factors. Another way to write this is 2 occurs twice, which is 2 squared times 3. Now, let's look at another example. Let's try 48. So we're going to create our factor tree here, 2, and then we have 24. So 2 times 24 is 48. Now we break this up again, 2 and 12. We break this up again, 2 and 6. we break this up again, we have 2 and 3. So what we see here is 48 is 2 times 2 times 2 times 2 times 3. And so we see 1, 2, 3, 4. So 2 appears 4 times 3. Let's look at some more examples. Let's look at a number like 45. So here, the smallest prime factor here is 3. We have 15, and then we have 3 and 5. So 45 is the same as 3 times 3 times 5. This is going to give us 3 occurs twice times 5. Let's try one more example here. Let's try 63. So 3 and 21, 3 and 7. So you can see here, an important thing to note here is that in this factor tree, all the factors right here are prime numbers. So what we have here is 63 equal to 3 times 3 times 7, which is 3 appears twice times 7. Let's take a look at some 3-digit numbers. Let's look at something like 168. So 2, we have 84. Divide by 2, we have 42. Here we got 2 and 21, and then we have 3 and 7. So therefore, 168 is equal to 2 times 2 times 2 times 3 times 7. We can rewrite this as 2 occurring 3 times, which is 2 to the 3rd power, times 3 times 7.